Hello everyone, my name is Darcy Fawcett. In this presentation I will discuss It Worked, Data Analysis Made Easy, an ongoing professional development initiative in the Gisborne Community of Learning. Through It Worked, I support schools with research-level statistical methods and data coaching so they can better plan, evaluate, sustain and share their teaching initiatives. Case studies will be presented and feedback from participating co-leaders will be discussed. The why. I hypothesise that if we continually use data to plan, implement and evaluate our teaching initiatives, we will progressively improve our practice and enhance student outcomes. The what? It Work consists of three components. 1. Research-level statistical analysis so that teachers can focus on planning, implementing and evaluating their initiatives. 2. Small group and one-to-one support so teachers and institutions develop more sophisticated inquiry and teaching practices. 3. Support with report writing and preparing presentations so that we can share our findings and plans with our teaching community. I want to quickly outline what the idealized It Worked inquiry cycle looks like. The standard data-driven inquiry cycle begins with a purpose or question, then data collection, analysis, interpretation, and then an action or decision, who are trying to continually improve their teaching practice and their area of responsibility. I visualize our inquiry as moving twice through the standard data-driven inquiry cycle, once looking at student outcomes, once looking at data about teaching and learning processes. The yellow highlights show the parts of the process that we focused on in 2018 to 2020, the green shading showing our new focus. As I will explain later, this new focus is possible due to the automation of the statistical analysis and the development of teacher-friendly online dashboards. I visualize the cycle beginning with collecting student outcomes such as NCA or PAT scores. Then the analysis of the student outcomes and the writing of the obligatory report. It Worked has improved this process by the introduction of research-level methods of statistical analysis and evaluation. If we decide the outcomes are satisfactory, and as we expected, then we continue with our current teaching practice. If the outcomes are not as expected, or we are unsatisfied with the outcomes, then we hypothesize about what teaching and learning inputs or processes may be causing this change in outcomes. It is important to realize that once you start looking, you can find improvements as well as reductions in student outcomes. In 2018 to 2020, we then skipped straight to the planning of our teaching initiative, for example, leading our departments in developing new resources or through some form of professional development. However, both the research literature and our experience show that our efforts would be improved if we held off on the planning of our initiative and first gathered data about whether or not we had correctly identified the true causes of these student outcomes. Such data may include classroom observations, student, teacher, or even parent voice, attendance data, and so on. Although it may take some time to gather and analyze this data and then evaluate our hypotheses, this is better than wasting our colleagues' time and effort barking up the wrong tree. Our next step is to present our findings and plans to our whole staff meeting. We are doing this not only to share exciting findings, best practices and our plans, but also to get input from outside our department or immediate curriculum group. Feedback on these conferences has been excellent. Although in 2018 we skipped straight to collecting student outcome data, we have discovered that our efforts would be improved if we monitored the implementation of our teaching initiatives. This needs to be done by collecting and analyzing data about the implementation of the teaching initiatives so we can find out whether we have successfully enacted our plans. Such data may include a schedule of peer observations so we can all give each other feedback on the new teaching strategies. Then of course we loop back to the beginning of the cycle and check to see whether our teaching initiatives have enhanced the intended student outcomes. To evaluate the effect of a teaching initiative, we need to compare two cohorts of students, one group who received the new teaching and learning and one that did not. To do this, we use either the experimental method or the quasi-experimental method. Similar to the natural sciences, in the experimental method we create two equivalent groups of students, teach the control group as normal and teach the experimental group using the new teaching and learning activity. Although this gives a direct evaluation, the experimental method is problematic in schools because there are a range of variables in play, so constructing two equivalent groups can be very difficult. In addition, excluding one group of students from learning that you think is beneficial is unethical. In the quasi-experimental method, we use the new teaching learning activity with our latest cohort of students and compare their results to previous years. Although avoiding the ethical and organizational problems inherent in the experimental methods randomized control and experiment groups, this historical or longitudinal comparison assumes that the current cohort is a representative sample of the historical population. Much of my work has been constructing historical records that go back far enough so that this assumption is valid. But the good news is that these historical records already exist. For example, NZQA has your NCA records going back as far as you want, and NZCR has your PAT records, and you can dig some of your history out of your student management systems. Colleagues were of course already analysing their assessment outcomes. Some were disaggregating their data, and a few were evaluating initiatives by comparing data from year to year. As well as developing the historical records, I have improved these evaluations by providing the appropriate research level graphical and statistical comparisons, and by supporting my colleagues as a data coach. Let's now look at a couple of examples. A primary colleague in my cohort had a gut feeling that the Year 2 students in her split level class were making more progress in writing than the Year 3 students. We used her overall teacher judgments for writing for 2017 and 2018 to find out. She recorded her OTJs using curriculum levels with 2 sub-levels, for example, early level 1, early level 2, and so on. We calculate their progress by finding the difference between her overall teacher judgments in February and in November. The bar graph shows the pattern we found. As you can see by the relative height or skew of the bars, the Year 2 students in blue look to be doing better than the Year 3 students in red. To confirm this impression, I ran the appropriate statistical test to see if this visual difference was significant. The statistical test gave us the p-value of 0.006, which in teacher speak means there is only a 0.6% chance that this visual difference would happen randomly. Other primary colleagues wanted to know whether their whole school maths professional development initiative in 2017 and 2018 had improved their mathematics teaching. Luckily, they were using NZCR's PAT mathematics tests with all their students twice a year, so again we could measure progress by finding the difference between their scale scores in February and in November. The graph above is a population pyramid illustrating the progress on PAT scale scores for each cohort. The blue graph showing the progress made by the 161 students in the 2015-2016 cohort is plotted back to back with the red graph showing the results for the 135 students in the 2017-2018 cohort. The length of each bar shows the percentage of students who recorded that amount of progress on their maths PAT tests. The red graph is skewed upwards compared to the blue graph, giving the visual impression that more learning took place in 2017 and 2018. The appropriate test for significant differences produces a p-value of less than 0.001, which tells us there is less than 1 chance in 1,000 that this difference would happen randomly. So we can say that the 2017-2018 average progress of 10.2 scale scores is significantly greater than the 2015-2016 average progress of 6.7 scale scores. So, one major way I support colleagues is by providing research-level statistical tests, and hence increase the validity of the evaluations and inquiry. The tests for significant differences are the most important. Their meaning is summarized by the p-value. Putting the technical definition to one side, I encourage my colleagues to view the p-value as the chance that any differences we find are the result of random variation. For example, some years are just more able than others. However, if you want to describe the size of the difference, you also need to test the strength of association. I encourage my colleagues to think of the strength of association as the size of the effect their initiative had on the student outcomes. If research level statistics seems daunting, don't worry. You don't have to understand the detail. Only one teacher in the community needs to be a statistician. Teacher statistician is my role in the Gisborne Community of Learning. Thanks to computers, all data analysis can be automated, and with a little training, a single teacher statistician can analyze and interpret all of their COLS data. Everyone else just needs to learn how to interpret graphs and to include statistics in their data stories. The next 2 slides show the statistical tests I'm using regularly in our COL and the alpha values I have decided upon. If you're a statistician, you might want to pause the video and read them. Everyone else, just let them wash over you. In 2018 and 2019, we found that most middle and upper leaders could not interpret the standard research level statistical outputs without one-to-one support. The mathematicians and scientists were fine, as they had learned these procedures as part of their own studies, but everyone else found the process of interpreting the outputs daunting. The two tables show the outputs for a single achievement standard. A secondary school headed department would need to inspect half a dozen of these for every subject, let alone the credit and endorsement distributions, or if you wanted to disaggregate by gender and ethnicity. But luckily there is a better way. The next section of the presentation is a video of one of the online dashboards I have developed that provides the research level analysis in a teacher-friendly manner. Oh, and the change of voice is my eldest daughter helping me to do the recording while I move the cursor around on the screen.
This video explains the NCEA dashboard used in the Gisborne Kahui Ako in 2020. Choose subject. On this first dashboard, the teacher selects the subject they want and then checks the enrollments and demographics. These graphs show the enrollment history disaggregated by gender and ethnicity. They are in boys' school, so the gender comparisons are irrelevant. At the bottom of each dashboard are focus questions. Total grades. This page shows the total grades produced by all the standards combined into one distribution. This table gives us the number of students in each cohort and the number of grades they produced. This population pyramid compares the grades for this year to the grades earned in previous years. Each bar represents the percentages who gained each type of grade. The skew on the graph shows that the grades have improved. This visual impression is confirmed in the grey table, which provides the outcomes of the appropriate statistical tests, the data presented in the requirements of educational research. For the less mathematical who might struggle interpreting the data table, when there is a significant outcome, the statement is highlighted rows. The tests are also disaggregated by gender and by ethnicity. The slices allow the graphs to be disaggregated by ethnicity, gender, and by teacher. Endorsements. The endorsement page is similar, but with one important difference. The students' names are now listed in this table. I have distorted the student names to maintain confidentiality. Another nice feature is that the table is linked to the graph. For example, if I select the excellence bar for this year, the table now only displays the students who gained excellence endorsement. Total credits. The next tab shows the total credits attempted and earned. It works in a similar way with a few changes now that we are dealing with numbers on a scale instead of ordered grades. This line graph shows how the median credits have changed over the years. The pyramid graphs show credits attempted and earned. The credits attempted and earned are grouped into categories of width 4. Internal and external credits. Tabs for internal credits and external credits are similar to the total credits tab. Standards. The standards tab works a bit differently. First, you have to select the standard you have actually done this year. After that, it is the same as the previous tabs, except that the data is not disaggregated by ethnicity and gender. Māori. This tab contrasts the achievements of Māori with non-Māori. There are 3 outcomes compared: the total grade distribution, endorsements, and the total credits earned. The first column of graphs compare the outcomes produced in previous years. The second column, the outcomes produced this year. Although not included in the Boys High report, when required, the gender dashboard is structurally similar to the Māori dashboard, but compares males with females. Summary. The summary questions at the end refocus the teacher's attention on using the data to evaluate their teaching initiatives. Now, one limitation with dashboards is that they are not set up for typing in your reflections. However, this can be overcome by exporting to PowerPoint. The export takes a couple of minutes. Once exported to PowerPoint, the HOD can type in the notes section. If stored online, it can be updated and shared as a Google Slides, allowing the other teachers in the department to review and follow up on the HOD's questions.
As discussed in the video, as well as presenting the numerical statistics, the dashboard produces a common language statement for each statistical test. This statement is highlighted rows when a significant relationship exists. Formal feedback from middle leaders who have used the new dashboards show that 70% of middle leaders now rate themselves as confident or very confident in their ability to interpret the statistical statements. This is nearly twice as many as for the various numerical statistics. 61% of middle leaders now feel confident or very confident in their ability to independently use and interpret the data in the dashboard report, rising to 100% with the support of a data coach. Most middle leaders feel the dashboard is useful or very useful for understanding student achievement, evaluating teaching and learning initiatives, and informing future actions. This level of confidence and use was achieved without expensive one-to-one coaching. Colleagues could access up to 12 hours of group workshops and average 7 hours each. Most middle leaders found the workshops useful or very useful. 65% for the initial presentation at the before-school HOD meeting, 68% for the in-school analysis and report writing, 70% for the across-school analysis and report writing, 72% for the in-school poster-making workshop. The massive reduction in one-to-one support was made possible by our co-construction of the interaction dashboard report. Most middle leaders found preparing their presentation useful or very useful in clarifying and collating their findings and in action planning. Most found the whole school presentations useful or very useful for sharing their challenges, goals and plans, and for understanding the challenges, goals and plans of other departments. A majority thought their presentation had an impact on their colleagues. The poster presentations are a really good way of sharing best practice. At our school conference in 2019, the leader of the Māori department explained that he was introducing wānanga in a drive to lift performance in te reo. Wānanga are a traditional Māori style of learning that enacts and embeds culturally responsive and relational pedagogy, with students and teachers collaborating for an extended period to reach a defined learning goal. Several other leaders, including the art and mathematics departments, were excited by this idea and introduced wānanga initiatives of their own. At our conference in 2020, the middle leaders of art and mathematics proudly reported their wānanga initiatives had produced significantly enhanced outcomes. The te reo initiative only been denied significance by small numbers. These presentations have had such an impact on our school that in Term 2 this year we trialled wānanga with every NCA class. 78% of middle leaders feel that the outcomes of the @work process were worth or very much worth the effort they have put in and are confident or very confident that their evidence-based initiative will lead to improvement. 78% are keen or very keen to engage in @worked again and are likely or very likely to recommend @worked to their colleagues at other schools. From 2018 to 2020, @worked has succeeded in supporting primary, intermediate and secondary schools in the Gisborne Community of Learning to make better use of their data to design, implement and evaluate their teaching initiatives. @worked 2018 and 2019 established that middle and upper leaders across the COL value research level analysis of student outcomes and can use this information to design, evaluate and share their teaching initiatives. However, it was also established that most middle and upper leaders are unable to utilize standard research level statistical outputs in this process without a whole day of one-to-one coaching. The solution to this barrier was the automation of the analysis and the presentation of the statistics in a teacher-friendly online interactive dashboard reports. Formal feedback indicates that middle leaders found @worked useful and valuable for analyzing and reporting on their data, as well as for evaluating, planning and sharing their teaching initiatives. Automation of analysis, teacher-friendly dashboards, collaborative workshops and data coaching are all essential components of the @worked process. Data coaches not only support their colleagues' understanding of research level methods, they also co-construct the analytical and support structures within their community. Only then do teacher and leaders fully engage in data-driven inquiry. Although the @work model requires much from a data coach, the required programming and professional development can be supported using modularization of software and models of distributed expertise. If you are keen to introduce similar data-driven inquiry and professional development into your school or community, please contact me to discuss how we can work together on this project. Thank you for listening.